Okay, for this last page, I am going to work both of the problems because they're lengthy and I want to make sure that you fully understand the directions, especially for the first one. Okay, so the first problem says, your friend Sammy solves the following problem. The teacher counted it incorrect. Okay, so if I were grading this, I said that it was wrong. Can you help Sammy figure out what he did wrong and write an explanation for what he can do to fix the problem? Okay, remember in class I said that that's the two parts of this problem. You have to tell me what he did wrong and how you will fix it. Okay, 10 points for what's wrong, 10 points for fixing it. Be sure to explain what mistake the student has made and what the correct answer is. Okay, so looking at the description inside the mind map. Okay, so the mind map is for parking garage costs. Remember we did a mind map in class for the plumbing, and you had the walk-in fee and then how much they would cost per hour. Well, now we're looking at a parking garage. And it says, at the north parking garage, it costs $5 to bring your car into the garage, plus $2 for every hour that the car is parked. Okay, so that would mean to me that my initial value, it costs $5 initially to park my car. So even if I only stay for 2 minutes, the moment I go into the parking garage, I have to pay $5. I know, it's a ripoff, but it's how parking garages work. So, to bring your car into the parking garage plus $2 for every hour. There's that keyword right there, every. Okay, that means that indicates our unit rate. That indicates what's going on in this problem. Okay, so we want to, it indicates that every single hour you're paying $2. Okay, so for me, my rate of change is 2, and my initial value, actually I'm not going to write this off to the side because I want to make sure that I have enough space for my work. And every hour, so this is my rate of change. Number 2 is my rate of change. Alright, so I'm just going to go straight down and look at the table. Okay, so for 0 hours, I have to pay $5. Okay, that looks good to me. That's my initial value. For 1 hour, I have to pay $7, which would be the initial value plus $2 for 1 hour, so that looks good. 2 hours, I'd have to pay $5 plus the initial value $5 plus 2 times $2, right? Because there's 2 hours for $2, which would be 9. That looks good. And then if I follow the same process, this whole table looks good. Okay, so I'm not going to need to write about the table because the table is correct. Okay, then I look at the equation. Oh, well, automatically I can see that Sammy mixed up the 5 and the 2. This should really be y equals 2x plus 5. Okay, so now I'm going to write about why this problem is wrong. Okay, I'm going to say this equation is incorrect because ... Okay, so you need to explain reasons why this is incorrect. The rate of change is actually 2, not 5. And the initial value is actually 5, not 2. Okay, Sammy mixed up the initial value and the rate of change. Any one of those reasons is correct, but you need to explain both. You need to explain that the initial value and underline that in red letters, initial value and the rate of change are both incorrect. Okay, this is a 20-point problem. I want to see as much work as I can get out of you for that 20 points. Alright, then I look at the graph. Okay, so the equation was wrong, the description was fine, the table was fine, but now I need to look at the graph. Okay, so the initial value, remember another word for initial value is the y-intercept. I'm going to write this right here. Equals the y-intercept. Okay, so that means this point right here should be 5, and it is. Halfway between 4 and 6 is 5, so that's perfect. And then I look at my table, or not my table, excuse me. I look at my table to look for these can be the ordered pairs that I graph onto the table. So I look at 1, 7, that one looks good. I'm going to put a dot on that one. 2, 9, that one looks great. 3, 11, that one looks good. And 4 should be up to 13, which it looks like it's about to stretch up there and reach 13. So the graph looks good. So the only thing that's wrong with this mind map is the equation and the way that Sammy solved it, because he switched the initial value and the rate of change. Okay, you have to check all 4 components, because on the test, just because the equation's wrong on the review, that does not mean that the equation is going to be wrong on the test. You need to make sure that you're checking all 4 components of the mind map. All right. Last problem on the review. I've given you an equation, a graph, and a table. Remember, our unit focused on characterizing linear equations and looking at multiple representations of linear equations. Well, here you go. This is as good as it gets, especially when it comes to comparing. So I've given you an equation, y equals 2x plus 75, where x is the weight in kilograms and y is the price. I've given you a graph that also has the same x and y values, weight in kilograms, price is the y values, and then a table that has the same x and y values. Weight is kilograms, price is the y value. Okay? And I ask you to please order the rates of changes from the above examples in order from greatest to least. Make sure you read that correctly. Greatest to least. So we're going to do biggest to smallest values. Okay? Largest to smallest values. So I'm going to find the rate of change in initial value for each of these, because it's just going to make it easier. Just like when we did the comparing functions with little squeezers and Bominos and Pizza Tent. Remember, I had you find the initial value and the rate of change for each of those. Same idea here. Okay? So the rate of change in this problem is 2, right? It's the number that gets multiplied by the x, and my initial value is 75. Okay, it's the number that gets added on to the end. That's pretty easy. Then I look at my rate of change initial value for the graph. Okay, I pick any 2 points, and my rate of change will be the change in y value divided by the change in x values. Okay? So my change in y value, I can do 0, 0, and then I'm going to pick this one right here, which would be 7, 150. All right, so my change in y values is going to be 150 minus 0 divided by 7 minus 0. 150 divided by 7. I'm sorry, I said this wrong. This is not 7, this is 7.5. So this isn't 7, 150, this is 7.5. 150. That's my mistake. Sorry, guys. But it is 150. Okay, so this should be 7.5 minus 0 divided by, so 150 divided by 7.5, which is 20. Okay, so my rate of change is 20. So we already know that that one's going to go in front of the equation, because the equation only has a rate of change of 2. And then my table, we're going to do the same thing. I'm going to pick these 2 points. Why not? Okay, from 2 to 6, I'm going to add 4. Then from 29 to 77, I'm going to add 48. Okay, so my rate of change, my change in y values, which is 48, divided by my change in x values, which is 4. 48 divided by 4 is 12. All right, so that means I'm going to put them in order from least to greatest. Nope, excuse me, from greatest to least. So my greatest rate of change is the 20 from the graph. So I'm going to put graph. And then next comes the table rate of change, which is 12. So I'm going to put table. And then last but not least is the equation with a rate of change of 2. Okay? My graph's initial value, I'm going to put these in blue. My graph's initial value is 0, right? It comes from this point right here, where the point crosses the y-axis. And then my table, I would need to subtract 12 from here to get to my figure 0. 17 minus 12 is 5. Okay, so my initial value is equal to 5. So that means on the next question, when I ask for the initial value, okay, I ask for the initial value from least to greatest this time. Now I'm going to put them in order from least to greatest. So least.
Coach Watson, please report to the testing room.